Our high-altitude balloon capsule contains two items, both separate experiments. One of these items is a small rubber ball. The idea for the ball hatched after we discovered that properties of rubber apparently change in space or high altitude. Our plan is to compare a ball that goes into high altitude to identical balls that have remained on Earth by testing their bounciness. We will also try to find the cause of such change by putting identical balls in space-like simulations. One simulation will be to put a ball in quarter temperatures and test if its bounciness has been changed. To test each ball's bounciness, we will use the standard bounce test. The standard bounce test will be as such. Measure and mark 4.5 feet above the ground on a wall, making sure to mark every foot from the ground for easier measurements later. Then, one person would drop the ball at the 4.5 foot mark. Another person will then mark the highest point of the ball's bounce. Lastly, someone will measure and record the height that the previous person marked. This process of drop, mark, measure, and record will be repeated 6 times. After the 6th attempt, the average will be taken. For consistency reasons, it is smart to first find a general range for the ball being tested. This range will not be recorded in the test, but is to find and exclude inconsistencies that may occur in the test due to an error in drop height or the ball not landing straight down on the ground. Our other experiment is quite simple, fun, and qualitative. We will see if pressure in high altitude will be so low that the pressure in a small bubble wrap bubble will explode outwards and pop the bubble. Our team's patch was heavily inspired by our squadron's patch. Our squadron's patch contains a phoenix with its wings raised high to resemble our strive for excellence and new heights. Both of these traits have been put into practice during the high altitude balloon challenge. The use of sunrise imagery was to allude back to the phoenix, as the sun rises from the ashes of night, or in a more applied sense, our experiment rising high up into the atmosphere.